Hello, everyone. Welcome to AICrowd Unscripted. And we have today some of the winners from the AICrowd Chess Challenge. And here we have Sumeet and Charu, who call themselves AGI noobs. And yet they managed to rank second leaderboard in the Global Chess Challenge. Before we dive deeper into the challenge and more on their solutions, I am super curious to know a little bit more about who are you, Sumit? Who are you, Charu?
Yeah, so I'm Sumit. I work at Databricks. I've been there for the past couple years here in Mountain View, California. I work in data infra primarily here. And before that, I was at Google for a few years and at a startup called Rubrik for 4 years before that.
I'm Charu. I'm a software engineer at Google in Mountain View as well. So I've been working at Google for 5.5 years now, and I mostly work on ad side, so YouTube ads. So I work on driving more revenue for Google. So mostly through how can we drive more ads performance through format optimization. So that's my focus area.
Right, that's great to know. And I saw in the profile somewhere that Sumit was also at ACM ICPC, right?
I was there 9 years ago now, yeah, in 2017.
Okay, all right. No, I came from a university back in India where everyone was just crazy about competitive programming, and ACM ICPC itself was like this huge thing that everyone was into. Good to have you here. Both of you come from pretty strong engineering backgrounds with a lot of hands on experience across the Google Databricks and the likes. How did you end up working on chess?
I guess the timing was right. It was Christmas. We found the competition. It felt like we could learn a lot. Yeah, this was our first competition, at least AIML related.
But this was your first time working hands on around SLMs or trying to post train some.
Yep, practically first time doing anything with ML models.
Same for you, Charu?
Yeah. So I had been wanting to do something like hands-on AI related since a long time, and then like we thought like Christmas, like work is free, so we have more time for personal projects. So and then this competition was coming up, so we thought like it could be a good way to learn something by doing it. So that's why we decided to sign up for this competition.
Right. I'm glad we managed to kind of present you an excuse on a platter, and I'm glad it was in the form of chess. Now, for us, it was always interesting because, again, it ended up becoming a very interesting test bed on which we can work on trying to train reasoning models in a very low resource setup, right? Without needing huge data sets, because you can synthetically generate a lot of data sets without a lot of preference data and the likes, because, well, you have strong chess engines and whatnot. And I'm glad to kind of see this both becoming a good excuse for you to learn, and then you along the way ending up winning the challenge. And this is kind of a pattern that I've seen across many A crowd challenges. So glad to have you here. Now, moving on to your solution, do you want to kind of tell at a very high level about your solution and how you kind of approached it, right? Because I want to know about the journey that you had from the first time fiddling around with the starter kit that we provided and the chess env to iterating on it and then getting stuck, I'm sure, multiple times, to finally having a model where you are like, I should be rank one or maybe rank two, I don't know. Then you're pushing really hard towards the end of the competition.
Yeah, we started with just trying to figure out a way to submit various models and see how they perform. And the first thing that came to our mind was do some prompt engineering. Maybe it works, maybe it doesn't, but that seemed like the simplest way to start. Did a little bit of that for the first couple days. And then maybe Char, do you want to continue from there?
Yeah. So we started with like some prompt engineering to see like how the base models perform. And what we found is like they were really poor at chess. So while they could output a answer, but like it wasn't even close enough to a legal move. So the legal rate was super bad. So yeah, prompt engineering didn't yield much results. Then we thought like maybe we can just fine tune the models on chess datasets. So if we can just take an existing like Quen 4B model and just fine tune it. So we tried that. That led to like a bit of the improvement, but it wasn't enough like a competition level. So it was pretty low ACPL still. So while it was better in the base model, it wasn't that good. We also thought like maybe we can try some RL on top of it. So we tried couple of algorithms like DPO, GRPO, but those also didn't lead to good results. So I think for the first like 15-20 days, we were just exploring a lot and trying to understand what to do. But we were in a phase where like we are in the 100 plus ACPL route where it's better than baseline, but it's not good enough for the competition. Yeah, so I'll let Sumit tell what happened next then.
Yeah. And then we realized we were spending most of our time on free GPUs, on Kaggle, Colab, and we were training about 20,000, 50,000 examples max, and that was nowhere enough to learn chess. And then I found this library Tinky by Thinking Machines. It felt like, okay, this is good. I can just use an API to fine tune a model. All I need to do is spend some dollars and hopefully it works. Spent a couple $100, all down to drain, got nothing out of it, but wasted a few days and got to learn a lot about it from that, especially because it rate really fast because it was all managed infra. All I had to do was write code locally, which obviously we have LLMs to do it. So that's where we spent the next couple of weeks.
But from Thinking Labs, that's the library you're talking about, but that focuses on the post training RLVR type of pipelines, right? And your
I
approach
think
was
that
SFT.
that library is general enough for whatever you want to do,
Mhm.
with some constraints on what hyperparameters you can set and those things. But we tried fine tuning using the library, using the API. We tried GRPO as well using the same API, and they had good scripts for us, especially because we are new to this. It was super easy to start doing things because of the library.
Yeah, so then I think like we were at a dead end like with this framework. So we thought maybe like we should think harder. Like, are we complicating the problem in some way? Like, are we trying to have an existing model and force it to learn chess? So what we thought is there's a lot of noise in the pre-trained model because it's trained on so many different data sources. So what if we actually take the architecture of the model but train it from scratch? So we changed a tokenizer for it so that it's actually optimized for chess. For example, every move can be a token instead of having the model predict like E2, FG, like as different tokens. If we just have it as a single token, so the model is then searching in a much smaller space of moves versus like the vast like knowledge it has. So we significantly scoped down the tokens for the model and then started training from scratch. So I think then we tried a small MVP approach. So we didn't want to scale it up before like getting some confidence whether this is working end to end. So we trained a small model and tried submitting it and see like whether it passes the criteria and also like leads to reasonable results. So I think that was the first time where we got like below 70 ACPS. So we felt like we got some confidence and it became a matter of then we need a bigger data set to actually move it from beyond like basic chess knowledge to actually like playing smart moves. So I think that's where the data set became very crucial for us. And then, yeah, I'll let Sumit talk about the data set and how we generated it.
Yeah. Okay, so we wanted a big data set and we didn't want to generate it ourselves. So I found that DeepMind had created a data set of about 500 million unique positions and it was available on their website. Downloaded it, and then we realized, okay, Kaggle and Colab is not gonna work out for this. Search for the cheapest GPU online and vast AI. We found that it was about $1 to $2 per hour per H100 or A100, and that's where we started scaling it up. Spent a few hours training the model there from scratch, and it seemed to play really well. At the same time, we noticed that it just wasn't able to finish the games. It would get into a winning position, have a win probability of 100%, and then start playing randomly at the end. And that was confusing because it's playing so well, it's making all this moves that we don't understand. And yet at the end, when it's so obvious what to do, it's just doing random moves. And that's when we realized that our data set had a bug that when it is in winning position, there are like all of these moves which will have 100% win probability. And the model is picking any of those moves because all of them have 100% win probability. But you need to make sure that you're winning quickly and not playing randomly at the end. And we had to do some data set fixes for that and completely start from scratch at that point. Did that again, submitted the model. We now see better win accuracy, but it's still playing this random moves at the end, ending up in loops, in threefold repetition, and still having super high draw rate, especially compared to everyone in the competition. We saw that our model had very high draw rate.
So what we found is like, so the initial data set we had, it had all the different games, but the problem with that the like non-bot AI Stockfish games is generally most of the games don't actually go towards the end game. So while our model had a lot of data points, it actually doesn't know how to finish a game because humans generally resign like when they actually reach the end game. So our data set didn't teach the model like how do you like end it with a checkmate and like how do you close out a game. So we thought maybe we need to have another data set for the end game specialization and skew some of our data set towards the end game so that the model can actually focus on that and learn how to do it. What we found is there was a data set where Stockfish was playing against itself, so that turned out to be a really good data set where the games were actually reaching the end. So that's an improvement we did to enhance our data set, and with that we found that it was reasonably able to complete the games. There was still the case that we have much more higher draw rate than other people, so we debugged a bit more, and what we found is there's this threefold repetition in our input. What we did was we gave the model the fen and the side to play, but we actually don't give the model any state of the game, so what move it is. And in chess what we learned is that if you repeat the move 3 times then it becomes a draw. And what our model does is like, because it doesn't know, like it already played the same move last time, so it plays the same thing again. So that was leading to a threefold repetition where we were getting stuck, and that was hurting us a lot because those games, if we actually look at it, we were winning those as well. That was another blocker which we found. And yeah, I think some of it was also because we are not that good chess players, like we don't know chess ourselves. Like at this point our model was playing better than us, so we were also learning these things on the fly.
In with a few questions in the meantime. It feels like a lot of your effort was around figuring out the data mix well. And it's kind of fascinating as well that you actually got the SFT based approach just to kind of work to end up actually winning. And I think you also have a pretty small model, right? Like a 50 million parameter model, which also makes sense if you're training from scratch. And the point that you mentioned about models struggling towards the end because, well, it has to win fast, not just win. As in, that is something that another of the winning teams also exactly basically also observed. And they were also using the exact same data set to train. And so that could also explain how you end up around the same wall. But that data set, the defined one, it was also kind of trained with RLE agent in mind, right? So then in states like that, you always assume that the agent's internal reward mechanism will take over and it will figure out that, okay, I have to kind of do this sequence of moves. But that's great. You briefly mentioned a little bit about your input representation and your tokenizer, the custom tokenizer. And especially when you're talking about actually training a whole model from scratch, it'd be good to actually get a view of how did you come about, how am I designing my tokenizer here, and like what is the input representation. And especially, when you are actually going ahead and saying, I don't care about language, I want my little model to just play. So you clearly didn't give any rationales, right? Which we didn't evaluate, but we were hoping a lot of people gave rationales.
Yeah, our tokenizer had no rationale. The rationale was it's the best move, basically. And how did we generate it? We figured out that there are about 1968 unique UCI moves at those, and then few more characters in the fan. At those, you get to about 2000, make it a power of 2, and 2048 is what our tokenizer was. And because we were generating it from scratch, we also ran into bugs like when we were trying to do multi GPU training. Every GPU was constructing its own tokenizer and it was not deterministic. And so each of them would have its own view of tokenizer and each of them would feel that everything is working fine. But then when you run evals outside of this, it's garbage. And so we ran into those kinds of issues because of our custom tokenizer, which took a lot of pain to debug.
No, that's great, right? But then, where else would you actually run into those problems and actually understand them firsthand, right? Another thing would also be, again, if you're literally training from scratch from this problem, you really don't have the traditional scaling laws and stuff to kind of assist you. So how do you even choose what how many parameters I want, or what's my vocabulary size? Many of those decisions, how do you think about it in first principles, especially for a completely new problem in a completely new domain that you're approaching? That's also could be interesting for anyone who's listening in.
Yeah, I mean, we just did a lot of experimentation, especially because both of us were super involved. Like, we trained models at 10 million, 25 million, 50 million, 100 million, and we were trying to find the best model which will basically improve the most per dollar. So that when we scale it up, we get the best result because we want to spend a certain amount of money for this competition. Yeah, so lots of experiments.
But did you document those experiments?
Did.
Yeah, we like an informal doc between us where we used to like track the results, but like not really like any like polished document. We were just writing down our observation and like syncing up and discussing. I also want to touch a bit on the rationale. So we did start with trying to include the rationale as well. But the main challenge there was there wasn't enough golden data set for the rationale. We tried couple of approaches. So there was some like Lichess had some annotated games by experts where they had generated the rationale. So that was one. We tried some rule based rationale where we take some aspects of the board state and try to feed it as a rationale. So we tried that. Then we also tried like taking a like super good model like a DeepSeek latest model or Gemini and try to have it generate rationale for our data set and use that to feed in the model. But what we found is like chess is generally so complex. It's very hard to explain why you do something in move 10 when it will lead to a win like 20 moves later. It's very hard like to fit it within the reasonable token size a good rationale, and the model generated rationale also had a lot of hallucinations. So when we actually debug it, it was actually very confident but like wrong like 50% of the time. We also tried something like forcing the model to generate a score for each state and use that as a rationale. But there also we found that the model is going into two different directions. So the best move and the rationale don't have a lot of correlation between them. So yeah, we tried a lot, but I think eventually what we found is like within the time period, it was just becoming like two different problems to tackle, and just the lack of data was one of the biggest challenges there.
Yeah, we also tried doing a warm start using human annotated rationales and then run GRPO on top of it and let the model figure out its own rationale. And when we did that, we found the rationale was pretty simple. It felt like it wasn't even relying on the rationale to generate the best move. Then we tried super long rationales as well, and that seemed to give good results, but it wouldn't have fit in the token limit that we had in this competition. Maybe if we had like instead of 2000 tokens, if we had 30,000 tokens for every move, I think rational would have actually started contributing a lot more.
Yeah, that's true. Actually, the constraints could actually influence. I think there's only one team. I think it was Ivanchuk's who had submissions which was actually starting to generate interesting rationales. On that note, I'm very glad without any nudges, everyone is very happily sharing all the negative experiments that they did, that I really love to kind of bubble up, because they actually hold a whole lot more interesting stuff than the final model which ended up winning. On that note, on the point of rationales, when we were kind of designing this benchmark, one of the motivating factors was, can we actually come up with something which allows us to do chess commentary of sorts? So parallel for that also, we wanted to kind of release a small data set and a SFT baseline, by the way, which we also released, which can help people get started, right? Especially people who may or may not be used to full training pipelines. So there we ended up doing two things. Of course, we released this template based data set, which was the chess explain one, but we tried some variations where internally we would take stockfish, and stockfish has these principal variations, right? The top two or three different lines it can go in, and we would pass in all these principal variations to say larger models like trillion parameter models, and then hope they would do a good description of it like a chess commentary. Did not work at all. And then our hypothesis was that these models, they basically have not been trained at all on chess, and they have a very rough perception of chess, And so any rationale they gave, there's no way it would make sense if these models themselves are performing at like a 1% win rate. We still have it as an open problem on how to meaningfully include the rationale as a part of the evaluation metrics. So more and more submissions on a benchmark like this really focus on getting the rationale right, because that has very interesting problems. But that itself is like a much larger research problem in reasoning on how do you ensure that the reasoning or your thought tokens are actually aligned with what your final response is. On that note, we managed to cover the fact that your the model setup, your representation, your tokenization, and your focus on the overall data strategy. But then, at least across all of them, many of the things that you did along the way, they were not very standard things that you would try, right? For example, a standard participant who is in there to win, they would not go for a standard SFT based approach, and they would definitely not try training from scratch. Even if they do try training from scratch, they may or may not be fiddling around with the tokenizer. And not many people would be bold enough to go ahead and just say, you know what, we will basically come up with our own ASCII board representation, although we did enable that with the prompt templates, etc., and then hope to figure out a large enough uh, data strategy. So along while you were doing all these experiments, right, and especially when you said you started in the beginning with zero experience in training any of these SLMs or the training pipelines, the whole ecosystem, at what point in the competition did you feel like, you know what, we are probably winning? When did that
Uh,
come?
I think it's when we found out the 50 million model. We trained it a little and it was already showing good results. And we projected that if we just let it train for a day or two, we are going to get like this can be top five, top three, top one. We don't know, but it's totally worth spending a couple $100 on this.
To be really honest, I think we both had like different expectations. So yeah, going into the competition, I did not think that we would even make it close to winning, while I think Sumit had more confidence. But yeah, I think the first time when we actually started seeing like we are able to pass the threshold, like I think 70 was the threshold where we were not able to break through earlier. And with this approach, we can see like the scaling is finally showing improvement, I think. And there was like couple of weeks where we were just like everyone was competing for the top spot. So like we make an improvement, we submit our model, we become the first, then another team submits it, and like there was a race. So I think that was the time where we felt this is real. At least we could get like somewhere reasonable in the competition. Yeah.
Right, no, that's great to hear. I also was curious, right? Again, not only about the moment where you felt, you know what, we have a chance, but along the way, you were probably also trying to get a quantitative sense of how you were performing, right? So, when you were internally running your experiments, were you keeping track of certain metrics, or what was your methodology so that you get a slightly richer understanding of how your model is behaving than just what we had implemented, which were the broad stroke metrics, which are anyway on the leaderboard, right? And the idea is your own internal metrics that you're keeping an eye on, they would kind of evolve as you get a better understanding of the problem. They inform some failure modes that you incorporate in your own evaluation harness. So I wanted to also understand the journey of that evaluation harness. How did it help bubble up some specific failure modes, and how did it look like towards the end of it? And manual inspection is also a part of the evaluation harness, by the way.
Right. I think we had lots of eval throughout the month or two. Initially, we started with looking at just the ACPL mean on some held out positions, as well as some puzzle accuracy again on held out puzzle. These were the two things we were tracking. And then we realized that because chess often in many positions you have multiple best moves, and just looking at whether you are matching the best move or not, it's not good enough. Like we want something more granular than this. And we came up with trying to rank all the moves for a given position and then see what rank are you hitting. Are you always in the top 3? Are you always in top 5? Are you in top 20% of moves, top 40%? And we're tracking this number and to see if it is going up across our runs or not. At the end, we also started building some self play and play against older versions of our model, play against Stockfish, and see how those numbers are showing up across models and across runs.
We had a like lot of different models at the same time, which we were trying to see like which one should be the one. And I think we didn't want to rely on just the metric being used in the submission. So I think we did a lot of eval within our own models to see which is the one which we should scale and push for submitting as well.
Yeah, like play against different level of Stockfish, play again, make model one, play against model two, do a tournament between them. We had 4 or 5 models training at one point simultaneously, trying to decide which one to continue scaling.
Yeah, I would say like for manual debugging, I did find the UI really helpful for the AI crowd chess visualization, like the way like you can debug, open each game and see what you are playing and how the game proceeds. I think just having that interface was really helpful for like doing a lot of manual debugging because at the end it became like the aggregate metrics don't tell the whole story. So trying to understand why the metrics are the way they are. So that's where I think the UI really helped us as well.
How often or how much time did you spend also snooping in on the visualizations of the other competing teams who were close to you?
A lot of time, yes. We were looking at that. We were looking at how much their memory utilization is, trying to infer the number of parameters they have based on that. Looking at the rationale, we could see that only Ivan seems to be the one who is having actually good rationale than everyone else. Either has no rationale or not any meaningful rationale. So for sure, we spent a lot of time snooping in. For our own, even for our own submissions, we could see just being able to see the win percentage being stuck at 100, and then we still end up in a draw. That was also helpful.
I'm glad all the credits for the dashboard actually go to Jyotish in our team. It was a little bit of controversial decision about how much information should be put out there because, well, there's chances of information leak and whatnot. But we said it's fine. It's a friendly competition in the name of science. That said, you were very curious about what the other participants were doing by looking at the dashboards, etc., etc. And what advice would you have for like new participant who just runs into this challenge today? What would you tell them to focus on first, and what do you think they should avoid wasting time on?
Okay, yeah, maybe I can go first. Yeah, so I think there's a lot of like fancy techniques like you can do. If you talk to like Gemini or any of the LLMs, like what should you do? Like if you start chess, so you'll see a lot of like RL, like maybe like GRPO is a good one. I think there's a lot of like fancy techniques coming up, but I think there's also so much power in just a base principled approach. I think that's one thing I would really recommend. Like start simple before like trying a lot of different things. I think that's one of the thing. The other thing is I think your data set is really like key to what you do. Your model can only learn as much as good as your data set is. So spending a lot of time not just like generating it but also understanding it, where what are its holes versus like where are the gaps. I think that's really important because once you fix the data set it's very easy to spin up a lot of different approaches and compare them because then you're controlling for the base data set. So I think that's the other one which I would really recommend, like get your data set right, start from this basics, and also like just learning being able to analyze your models is a really important skill, not treating it like a black box but really trying to figure out what's working and what's not working can be helpful. So yeah, and then it's also about the amount of time you can put in. So the more you put in time, I think the better results you will get. But yeah, that's what I would recommend. But yeah, Sumit, if you have any thoughts.
Everything that you said, and I think evals really helped us to understand whether we are improving or are we stuck, because you have so many different ideas you want to try, and if you don't have shared eval, there's no way to compare things. So I think that really helped us.
That's good to know. How did it compare, Sumit, from classic competitive programming experiences?
This was way more open-ended, and it made me a lot more uncomfortable because you were starting from scratch. We were noobs, as they say. Compared to classic, I think just because it is so open-ended, then there is no single answer, and is way longer than a classic competition, which is generally couple hours, ICPC, and this is a month or two.
Well, welcome
Um,
to research. On a similar note, right? Again, from just from a few months ago when you mentioned that you had zero experience, on just opening up an LLM or trying to train one to one, actually doing a pretty good job at actually getting this small language model to behave on chess. And also from the way you described your story and your journey around it, you've pretty much gone through all the motions and all the emotions that most researchers would experience while they're training a larger model, except at a slightly different scale here and there, but you pretty much understand the whole flow. So did this experience kind of also somehow encourage you to kind of follow and do a much deeper dive into the field? And if it's so, like, how do things look there? What are your plans? What you already have been exploring after the competition?
Yeah, totally. So we realized we are weak on the basics and the fundamentals, and we started doing a couple of courses, and that's what we have been doing for the past month. And now that we have seen everything practical, it is easy to connect those things to the theory that we are learning and see the implications of it. Like, okay, learning rate, how does it matter? Why were we facing those issues? Why were we seeing gradient explosion? And now when you read the theory, it is easy to connect those things.
All right, that's great to hear. And it has been a treat talking to you and finally getting to meet the faces behind the user handles. Congratulations again on winning in the Global Chess Challenge on AI Crowd. And we would also thank AWS and AGI House for helping make this happen and co organizing this with us. I will not take more of your time. So thank you for joining us today.
Yeah, thank you.